Okay, very good afternoon to all of you, Veda. Today we are, I just shut him out. Enough. Yeah, we are going to start today with periodic table. Yeah, okay. We have this boy here. Ek minute, Veda. This boy here. Leave. Come here. Sit in the first bench. First bench. Okay. Very good afternoon to all of you, beta. Today we are going to start with what? Periodic table. Okay. Now, let us go to the periodic table. We go to the...
So there's a lot of history in this, no?
Yeah, a lot of history and... Okay. Now, beta, if I tell you to do shopping, okay? So from where, which place you will shop? This place 1 or place 2?
But like all of them are women clothes.
No. But for quick shopping, quick. So here, because from here you can make out what type, what is the size and everything, right? The pattern. Okay. Yeah. So which one will be more convenient? Place 2. Why? Because it is systematically arranged. It is systematically arranged. If I tell you beta why, because the arrangement is done in systematically. Okay. So shopping becomes easy. Now, beta, if I tell you to pick a book from a particular rack, so from there you will pick. Because it is very systematically arranged. So now, beta, similarly, if you see in periodic table, beta, there are so many elements. Okay. So therefore, beta, we know in periodic table there are many elements. So yeah. Beta.
Sorry, sir, my bus got late.
Okay, no problem, beta. Look, beta. Beta, we have just started with the chapter, the periodic table. Dalmia, beta, bus ho gaya tumhara. If I tell you to pick up the clothes from where you will pick, beta, from place 2. Why? Because this is very arranged systematically. If I tell you to pick up a book from which place, you will pick up from the place 1. Why? Because it is arranged systematically, it will save time. Similarly, in periodic table beta, there are so many elements, 118 elements. So what we have done, scientists have done, they have placed all elements having similar property in same place, in a particular place in periodic table. But beta, earlier, the periodic table was not the one which we see nowadays. Look, yeah, I'll tell you beta. Hey, listen. Now, earlier, if you see, we never had mobile phone. Okay. We used to write letters. After letters, what came? Telegram. After telegram, what came? Pager. Right? Then telephone. Right? Then your wireless phone. Then came mobile phone. Then your touch screen phone. And now, lot of how the phone evolved. Yeah. Similarly, periodic table also has evolved over the years. So earlier, few scientists came up with the periodic table, but there were some drawbacks in that. So another scientist came and classified in a particular manner in order to rectify the drawback of the previous one. Then this thing went on happening, and then we got the modern periodic table. Earlier, scientists classified the element in the which form beta they classified them as what? Metals and non-metals. So they've earlier classified them as what? Metals and non-metals. But this classification failed. This classification failed because we had certain metals, certain elements. We had certain elements which showed property of both metals and non-metals. Metals, beta, आवाज नहीं आना चाहिए जरा. Metals and non-metals. So metalloids. They showed property of both metals as well as non-metals. Clear? So that was metalloid. So that earlier classification failed. Then came the first scientist who classified the element His name was Dobberainer. What was the name? Dobberainer. Dobberainer. Okay, Doberman नहीं है, Dobberainer. अच्छा. Now he classified the element. Now look, beta, initially three scientists which we are going to study, he classified the element on the basis of atomic mass or atomic weight. Atomic weight. Atomic weight. What is atomic weight, beta? In an atom, at the center, we have nucleus, proton and neutron. And what is revolving around it? Electron. But the mass of the element is concentrated at the center. So it was basically the mass of the nucleus when we talk about atomic weight. Clear? So the first one to classify was Dobberainer. And he classified the element in a group of three. In a group of three. So let us see. The first, Wolfgang, Dobberainer, इसका पूरा नाम है बेटा. Yeah, Wolfgang. Johann Dobberainer.
Good boy.
He arranged the element. What was his basis? In MCQ, they will ask one question. What was the basis of classification of Dobberainer? So what will say? Atomic mass or atomic weight. He arranged the element in a group of three. Yeah, similar element in the increasing order of atomic weight. Dobberainer arranged the element in which order? In the increasing order of atomic weight in a group of three called as, three means tricolor, like beta tri, so triads. How he arranged the element, beta? He arranged the element, beta, in a group of three like this. Which were the three elements? Lina, K. Lina, K. Okay. Achha, if the atomic weight of the first is A, then this is B. Then what was the atomic weight of the middle one? A plus B by 2. A plus B by 2. This was it. When he arranged the element in the increasing order of atomic mass. Iska atomic mass was 7. This was 39. So what will be the atomic mass of the middle one? Divide by 2. So what answer will get?
Sir, the formula should be.
Are you getting it?
Yeah, sir.
So how many? This is how many column, beta? 3 column or not? Therefore, it is known as triads. So how we arrange the element? When the chemically analogous means similar element. When chemically similar elements are arranged in the increasing order of their atomic mass in a group of 3, then the atomic weight of the middle element was found to be average or arithmetic mean of the atomic weight of the other two. Clear? Okay, in exam, what all type of question will come? Look, beta, they will give in exam. There is an element X and there is an element Y. They will give their atomic number, A, B, whatever. Then they will tell you if it is a part of a triad, then what will be the atomic weight of the middle one. So what you are going to do? Yeah, but they will give you some value. So we'll be able to do it. Clear? Right? Hello. So he arranged the element in the increasing order like this, beta. Can you see Lina K? Right? They will ask Lina K. Lithium, sodium, potassium, then the atomic weight. Can you see if I take 7 and 39, if I add them, what I get? 23. And actually it was how much, beta? 20. But he will use this word approximately. They are what, beta? Approximately. Approximately equal to. Why? Because sometimes it was not coming exact. His classification failed. His classification failed. Why? Because it was not applicable to all the elements. It was not applicable to. So what I want all of you to do, beta, in your textbook, there is a page number 79. The heading is what? The periodic table. What it is? The periodic table. Beta, you will directly come to page number 80. And you will come to this part, triads. And first you will mark. First, in exam, what they will ask you? Define triads. So what you write? Dobberainer arranged the element in the increasing order of atomic weight in group of 3 called triads. So mark this, page number 8080. Mark it, come on. Mark it right now. 8080. Then beta, what is Dobberainer's law? Please. बेटा मैं ना तुम लोग को तीनों का मैं पति में लास्ट वार्निंग दे रहा हूँ. बस हो गया. तेरा ना तेरे को यहाँ पे आके बैठ जा तू यार. Second, chemically analogous elements when arranged in the increasing order of atomic weight, well marked in a group of how much, beta? 3. So this is a group of 3. Can you see this? Analogous means similar. Chemically similar. I told that also. You are busy talking with Dalmia at that time. In which the atomic weight of the middle element was found to be average or arithmetic mean of the first and the last. Now, beta, look, I want you to write here. If this is A, this is B, then this is what, beta? A plus B by 2. A plus B by 2. Please write it for your reference. If the first one is A, the third one is B, then the middle will be what? A plus B by 2. A plus B by 2. Now in exam, they will ask you, write the third member of the triad. They will give you lithium, sodium. Then use the third member, potassium. Or they will say, write the middle one. Lithium and potassium is given. Then who is the middle one? Sodium. Yeah, only these three. No, better there were many. But he used the word approximately. Sometimes there was a difference of 0.5 and something like that. But it's not. So now then, beta, what is the dracha? I'll show you that also for your extra knowledge. Nobody will ask this. Okay, now I'm going to take beta kasturba.
What?
Calcium, strontium, and barium. Okay. Calcium, strontium, and barium. Okay. Now, strontium, it is not strontium, strontium it is. It is not a Latin name, proper name. Hey, girls, here, look, if I take average of these two, what answer I was getting? But was it exactly equal to this? Therefore, he used the word approximate. Acha, he failed also.
So she does like
Failed. He failed also. I know.
Sir, when you search atomic weights on Google, now it gives you some random number 0.456.
Just shut your mouth and pay attention. Okay. Beta, now I'm going to take Neha path. So nitrogen, phosphorus, and arsenic. Okay. Okay. Hey, batch. So look, if I take the average. So if I take the average, is it exactly equal? Is it approximately? No, no. अरे ऐसा मैं ऐसे लिख सकता approximate? Not in. Here I can write this. So this fellow failed. Nobody will ask all this thing. Understood? So this failed. Why failed? Oh, hence this rule is not followed for all triads. Therefore he failed. Limitation. Okay? Not holding true for all elements. Oh, failure. The exam they will ask the failure. What was his failure? Bleach. This is your failure. Mark this. The not holding true for all elements. Bleach. Mark this. Not holding true for all. Anya Mehta, why are you still late? Huh? Anya Mehta, why are you so late? सो गई है क्या? Anya Mehta, very bad. I'll tell everyone to put their video on, beta, if you are not going to respond then. Or okay. Okay. Anyways, now. Okay. Tavadians. मार खाएगा. Now, beta. Hey, he failed. He failed. Then listen. Hey, that's weird. So, hey. Then beta, he failed. So beta, now his classification failed. So we have to come up with the new classification. So another gentleman came. His name was Newland, John Newland. Okay. He also arranged on the basis of what? Atomic weight.
Yeah.
So first gentleman failed. So now we have the next one, Newland's law of octave. John Newland. Look beta. Toby Reiner failed. Toby Reiner, what he did, he arranged the element in a group of three such that the atomic weight of the middle element is the average of the first and the last one. But his classification failed. Why? Because it is not applicable for all the elements. Then beta, who came the next gentleman, English scientist, his name was John Newland. Look at him. Yeah. 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 Okay. Okay. Now, hey, he arranged the element in the form of, increasing order of atomic weight only. Increasing order of atomic weight. He also arranged the element on the increasing order of atomic weight. Hey, Newland's law of octave. He arranged the element in the increase. These are the atomic weight, beta. These are what, beta? Atomic weight. Pay attention here. All these are atomic weight. Can you? I'll tell everything. Just shut your mouth now. All these are atomic weight. All these are atomic weight. ए बेटा बस हो गया भाई उठ जाओ बोला ना उठ दोनों तू भी उठ दोनों जान
You asked to unmute. Did something happen?
या अन्य नॉट अ प्रॉब्लम बोथ ऑफ यू मैं उड़ जाऊंगा बहुत मारूंगा फिर मैं भी बोल जाऊंगा नो 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 कम आउट नो नहीं बोला मैं उठेगा ना मैं भगा दूंगा पहले बोल देता क्लास के बाहर ही भगा दूंगा उड़ रहे उड़ यहाँ पे शाना समझता है उठ बोला ना तो उठ वहां से तेरा सामान ले चल इधर बैठ इधर नहीं बोला ना वरना घर पे जा जा ए तू शाना मत बन तू भी निकल यहां से चल नहीं बात नहीं वो क्या कर रहा था मैं देख रहा था तेरे को 10 बार बोला तेरे को शाना बनता है क्या ए इधर आ बैठ इधर 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 आ तू मेरे फर्स्ट बेंच पे आ जा वैसे भी तू कुछ लिखने वाला नहीं है देख क्या है चुपचाप लोगों को एक बार बोलता ना समझ लो मैं कुछ बोलता नहीं उसका मतलब ये नहीं दिमाग ना सही बताता हूँ बहुत ऐसा बैंड बजाऊंगा ना समझ जाएगा तू ए क्या रे चलो बेटा he also arranged the now look Newland's law of octave he also arranged the element in the increasing order of what atomic mass only atomic weight or atomic mass right all these are atomic
Excuse me,
mass.
sir.
Yeah tell me
So, did you do that Dobereiner
Yeah,
person?
we did everything,
The
but I'll again
Dobereiner
tell you,
law.
I'll quickly revise what we did. Look, first of all, why elements
Yes,
need to be
sir.
classified? Earlier, elements were classified as metals and non-metal. But then, beta, we had metalloid, so that classification failed. Then, who was the first gentleman to classify? Dobereiner. He arranged the element in a group of 3 in the increasing order of atomic weight. Okay, 1, 2, and 3. If this is your A, this is your B, then the atomic weight of the middle element is arithmetic mean of other two. So this is 7, then this is 39. This will be how much beta? 7 plus 39 upon 2. So that will be how much? 23. So this is known as Dobereiner's law of triad. But he failed. Why he failed? Because this was not applicable for all the elements. I'll quickly show you this beta. Look, what was Dobereiner? What Dobereiner did? He arranged the element in the increasing order of atomic weight. Can you see this? Okay. If the atomic weight of this is A, this is B, then what is the atomic weight of the middle one? A plus B by 2. Okay. So if look beta, 7 and 39. Can you see? You take the average. How much you are getting? 23. Right? But his classification failed. Why? Because it was not applicable for all the element. If you do this element beta, can you see this last example I'm just showing? Nobody will ask this. Is this the arithmetic mean? Actually, if I take average of these two, what I get? 44.5. But actually it was how much? So can I take it as, no, beta, not applicable. Therefore he failed. So failure. So in textbook beta, I have given marking also on page number 80. First thing what they will ask you, define triads. What are triad? Look here. When Dobereiner arranged the element in the increasing order of atomic weight in a group of 3 called triads. Then Dobereiner's law. Chemically analogous means similar element when they are arranged in the increasing order of atomic weight. Well marked in a group of 3 called triads. Then the atomic weight of the middle element is what? Average of the atomic weight of other 2 elements. First question they will ask what are triads, then Dobereiner's law of triad, then sometimes they will tell you give example. So Li, Na, K. Got it? Lithium, sodium, potassium. Then he failed. Why he failed? So A भी पूछेगा. What was the failure of Dobby Reiner? Then what was the failure? Not holding true for all. Then beta the next gentleman came. Who is the next gentleman? New Zealand नहीं, Newland. John Newland. John Newland. Okay, he failed. What not applicable for all element? John Newland. He is the English scientist. Look. He also arranged the element in the increasing order of atomic weight only. He also arranged the element in which order? Can you see this beta? These are atomic mass. Huh? This is atomic mass or atomic weight. Acha, he was fond of music. So if you know in musical notes, if I start from here, look, if I'm writing here sa, re, ga, ma, pa, dha, ni, sa. Again, I'm getting sa. So this sa is coming or not? So what is that? This element and this element, where the musical note will be same musical note is there. These two elements will have similar property. These two elements will have so देख तो ये साथ सा हो जाएगा रे रे so who तो lithium and sodium will have similar property रे रे this will become रे रे or not tell me so these two will have what similar property but if you count the number so if this is which element first this is what second third fourth fifth sixth seventh and this is what eighth so can I say every first and eighth element has similar property as in octave of music Sare Gama Pada Nisa, first and eighth element. How will you say that? No. He started with this thing only. Yeah.
Second and ninth will be similar.
Yeah, second and ninth means every from whichever note I'm starting. So that first and the eighth element. Yeah. So I'll tell you. So look, elements when arranged in the increasing order of atomic weight, they show resemblance in their physical and chemical property. With which element? First element and the eighth element. As in the musical. So in exam, what I can ask you, who is octave of, why we use the word octave? Okay, because first and the eighth element. Who is octave of lithium? Sodium. Who is the octave of beryllium? Magnesium. Are you getting it? So I'll just show you here. Where it is, bro? Oh yeah, here it is. Come on, man. Look here. And chalo. Copy line, Newland. Take beta. 1, 2, 3, 4, 5, 6, 7. Look. If I play the musical note, then what I'll get, beta? Come on, look. Sa, re, ga, ma, pa, da, ni. Again, what I'll get, beta? Sa. So, this will have similar property. Are you getting it? These will have similar property. This will have similar property. Are you getting it? Hello. Yeah, so but now beta, during his time, very few elements were there, and during his time, beta, noble gases were also not. Therefore, his classification also failed. So it is applicable up to calcium, but beta, in your notes there in textbook, they have given up to potassium. Beyond potassium, it is not applicable. So we'll remember that only. Beyond potassium, it is not applicable. So if in exam now, what type of question they will ask here? First, what is Newland's law of octave? Secondly, they may ask, who is octave of lithium? Sodium. Then last, why he failed? Why he failed, beta? Because this is not applicable below beyond potassium. Beyond potassium. Clear? Okay. He has written something here, odd grouping. So this you won't understand right now. But then too, I'll show it to you. Look, I'll just show it to you. Show you. What was his odd grouping? Look, beta, this we have done do re. Acha, if you write in English, what are the musical notes? ये देखो बेटा वो भी मैंने दे दिया है डो रे मी फा सो ला टी डो ऐसा again are you getting it odd grouping beta can you see this was the odd grouping hello this was the odd but nobody will ask and you're not supposed to remember this so beta he failed not applicable beyond potassium clear right beta please I want you all to mark this what was his failure. So look here. Okay. Hello. You can failure में what you can mark odd grouping and failed with heavy elements beyond potassium. Please mark this. Heavy element means mass. As you go, if you go higher than potassium, the mass will keep on increasing, na beta. because atomic mass number increases. Mass number will increase in proton and neutron, and these all basis of classification was what? Atomic mass. Now, beta, who is going to come? Russian is going to come now. Let us see. Yeah. Okay, beta. Now this also failed. The first Dobby Reiner failed. Then who failed? Newland. Then who is going to come? The new scientist. Russian is. Okay. Yeah. His name is Ivanovich Dmitry Mendeleev. Beta, we can spell it in 4 different ways. Okay. Mendeleev. Okay, Mendeleev. Russian, na beta. Okay. So look here. Hey, hello. Look, beta. Look, this is Dmitry Ivanovich Mendeleev.
I can see my phone.
Okay. So he was a Russian chemist. Okay. Chalo, beta. He is known as father of classification. He is known as, he was the first one to classify element in the groups and period. In the groups and period. Okay. And what he said, the physical and what was his law? The physical and chemical properties of element are periodic functions of their atomic weight. Okay. What was his law, beta? Look, I'll show you, beta. Dun, dun, dun. What do you mean by periodic property? Periodic. What do you mean by periodic? So first, beta, what was this is his statement, beta. What was his law? In exam, first they will ask you, hey, what was Mendeleev's law? The physical and chemical properties of the element are periodic function. What do you mean by the word periodic? Periodic functions of their atomic. No, periodic means, okay, any process which is repeated at a regular time interval. You have sunrise, sunset, sunrise, sunset. In your school also, suppose on Monday you have a specific timetable, then next Monday also the similar timetable we follow or not. Any process which is repeated at fixed interval, that is known as periodic property. Okay, regular time interval. And what do you mean by periodic? Phenomena which is repeated after regular time interval. Clear? So this was his table, and what he said in his table, let us see. Chalo. He arranged the table in this way that boys there get up man. घर पे सोने का तो घर पे जा. यहाँ पे देख. ना वरना तो पूरा टाइम ऐसा ऐसा आंकड़े के जैसा बैठा रहता है क्लास में. अभी क्या हो गया? हाँ मालूम है तू बहुत थक गया. ये अरेंज एलिमेंट इन देखिए. वर्टिकल कॉलम्स आर नोन एज ग्रुप. टेबल में ऐसा वर्टिकल कॉलम को क्या बोलेंगे बेटा? वील कॉल इट एज ग्रुप. एंड हॉरिजॉन्टल आर नोन एज पीरियड्स. ओके, हॉरिजॉन्टल बेटा ऐसा आएगा. देखिए हॉरिजॉन्टल. अच्छा, आप लोगों को मैं एक ट्रिक देता. बच्चे भूल जाते ग्रुप और पीरियड में. तो बेटा यू रिमेंबर दिस. हार्दिक पांड्या, यू विल रिमेंबर हार्दिक पांड्या. Hardik Pandya. So take the initial. What is the year Hardik Pandya का? HNP. So horizontal period. ये याद रहेगा. Horizontal period. Clear है? तो vertical क्या होगा? Group. Okay. Horizontal period. Now I'll show you his exact table, beta. But the table which is they have shown in your book, beta, that is absolutely wrong. Okay. This is his actual table. I'll show you. This is his actual table. This is not given in your textbook, beta. No, not in. This is not in. His table is this one. Look, in your textbook where they are given. Look. Yeah. This is stupid table they are given here, Mendeleev. But here on this page, what all thing will mark first? First, what will mark? What are periodic properties in exam? They will ask. Okay. The properties, please mark this. The properties which repeat themselves at regular time interval are called periodic properties. First, they will ask you, what are periodic properties? Which repeat themselves at regular time interval are called periodic properties. Clear? सब बताऊंगा मेरा शांति कर एक एक करके बताऊंगा. Then what is, mark this, what is Mendeleev periodic law? What is Mendeleev periodic law? The physical and chemical properties of the element are periodic functions of their atomic. This may come for, fill in the blank or MCQ. In Mendeleev periodic law, the physical and chemical properties of the element are periodic function of dash. In option, they will give you atomic number, atomic weight, okay, nucleon number. What will be your answer? Atomic weight. Clear? The table which you see here, this is absolutely wrong table, beta. I'll show you his exact table, beta. Look here. Acha, then beta, they will ask you what was the Mendeleev contribution. This question will come for 2 marks. This question will come for how many marks? 2 marks. Mendeleev's contribution. So first he arranged the element in this. Can you see this vertical column? They are known as group. And this horizontal, they are known as what, beta? Periods. Horizontal are periods. So look here, they have written horizontal row period and vertical column. And beta, if you see, he arranged the element which are in the same group, they have similar property. Element which are they are in the same group, they have what? Similar property and same valency also. चलो मेरे को बताओ लिथियम का बेटा क्या होता था लिथियम लिथियम व्हाट इज द वैलेंसी इट एटॉमिक नंबर इज 3 ना तो 2,1 so valence is 1 sodium is how much beta yeah so 281 so they have same valency or not tell me beryllium it is what 2,2 magnesium it is what 282 so they have same valency or not tell me so look this is written elements in the same group element in the have same valency and similar chemical property.
Why is there group A?
That I'll tell you later. This is absolutely wrong. Okay, that is what I was saying. Table, the one he is given here in the textbook, it is absolutely wrong. I'll show you the exact table. Now, beta, his table, he left some empty space. Beta, I'm going to show you each and everything. Look, this is his table, beta. Can you see he has kept some empty space here? अरे आ जाना भाई. ये देख, this is his table. Now see ये हीरो, ये देख ये actually ऐसा table था.
बीच में जगह पे
हाँ तो वो उसने छोड़ा था. He arranged the element in the increasing order of atomic mass. And then, beta, when at that time only that many elements were discovered. But what he thought between here and here, some other element should be there. So what he did, beta, at that time that element was not discovered. So he left that empty space there. But he predicted the property of the element and they were found to be perfectly correct. Achha, now where it is placed, beta, beyond boron it is, na, beta, beyond. Beyond means Ika. What we'll call it as Ika boron. बोरॉन के जो नीचे उसको हम लोगों ने क्या बोला बेटा इका बोरॉन एल्यूमिनियम के नीचे कौन है यहाँ पर भी खाली जगह है कि नहीं बियॉन्ड एल्यूमिनियम इका ही नेम्ड इट एज इका एल्यूमिनियम एंड बेटा एच ए कैन यू सी बियॉन्ड सिलिकॉन देयर इज अ प्लेस सो ही कॉल इट एज इका सिलिकॉन तुम्हारे सिलेबस में भी इतना ही है बस ये थी या दैट इज इका ओके But you have to remember only this thing. But after this discovery, Ika boron was known as scandium. Ika boron was known as Ika aluminium was known as gallium. And Ika silicon was known as germanium. Achha, this will come for math the column. On one side I'll write Ika boron, Ika aluminium, Ika silicon, and on the other side I'll change the order. Or this will come for in MCQ also. Ika boron is known as dash. I'll give you scandium, gallium, germanium. What will be your answer? This is very, very important. This comes in exam very frequently. Okay, look, beta, if you read this chapter from textbook, you won't understand. Look, from here, you are able to understand his table. He left some empty space. Can you see? Right?
empty space was group A.
Here I am showing you, na, beta.
Table is wrong only.
This table is wrong only. Okay? What I want all of you to do, beta, please, this Ika boron is known as what? Please mark this, scandium. Hey baby, mark this. This is very, very important. Ika aluminium was known as what? Gallium. And Ika, you write, actually you write here horizontally in front of each other. And Ika silicon. After discovery, it was known as what? Germanium. Clear? This is very, very important, man. Very, very important. This will come from math the column or in MCQ it will come mark. Okay, Ika boron, Ika aluminium, Ika silicon, Ika bhai. Okay. Achha, incorrect atomic weight of few elements were corrected. So this was his contribution. Achha, you are marking, mark it. Hey, just remember one attention. ये बस रहे मार्क किया क्या टेक्स्ट में सुनिए मैं बता क्या क्या देगा राप्टा एक व्हाट मैन बोल रहे हैं
सर ये लोग सर यार
बोला अरे बोला बोला अभी बोला ओके चलो बस ये दूसरा हाथ से छोड़ेगा तेरा पे कौन ये डिनर एक खाली समझ लो ना झोपायचं नाही बरं का. चला पुढे जाऊया. चलो ओके. Hey, this question will come for 2 marks. Huh? अच्छा, what are the important thing? This one will definitely come. Ika boron, ika ये वाला पूरा याद आ रहा है ना बेटा? Only 3 you have to remember. That's it. Look, I have given here also again, and I'm going to share this in the group. Look, beta, he has left this empty space. This was beyond boron, na, to Ika boron. This was below aluminium, so Ika aluminium, and this is Ika silicon. And after discovery, what was this? He predicted, and he left the empty space. But whatever property he predicted, they were found to be correct. Look, scandium, gallium, and germanium. देखो इतना अच्छे से बताया यहाँ पे देखो. ए भाई तुरकिया देख इधर. Clear है? Now look in MCQ they will ask in this manner, beta. Look, tan. This is very important. Look, I have given here. You have to remember this. Ika boron, scandium. Ika aluminium, gallium. Ika silicon, germanium. Now, beta, next question they will ask for 2 marks. What are the failure defects in Mendeleev periodic table? What are the defect? Defect में पहला ये है. How he arrange the element? Shruti beta, don't sleep and you tell me beta how he arrange the element in the increasing order of atomic weight. अभी बेटा यहाँ पे देख गौर से. ओए बात ना करे उठा के पटक दूंगा मैं.
36.
नहीं 56. Okay.
all the remaining
At that time, whatever element where he was knowing, only those elements he arranged. Therefore, his table is also wrong, beta. Now that is why we are studying. Now, what was his failure? Boka. Boka means manzar, as a manzar. Beta, please stop playing nigga in the class.
Stop playing.
Okay. This girl here. Arey beta, that table is wrong, beta. I am telling you now which is the correct table. Okay? This is Mendeleev's table. Hey. Look. What is going on? Wait. Mendeleev क्या?
Dimitri Ivanovich.
Hey, look here. Hey, dalmia इधर देख. He arranged the element in what? Increasing order of atomic mass. But can you see these two? Is it in the increasing order? Who is bigger? 58.9 or 58.7? 58.9 is so. Hey, everybody asked him, "Arey, why have you placed cobalt in before nickel?" So he had no reason for that. Clear? But he said one thing: if I shift nickel here and cobalt here, then it will not match with the property in the same group. Therefore, he said, no, I have kept this way only because otherwise what will happen? The similarity will get disturbed. So, ये pair को हम लोग क्या कहते हैं बेटा? Anomalous pair. What do we call this as? Anomalous pair. ऐसा बहुत सारा था. ये भी देखना बेटा. यहाँ पे भी देख रहा है ये. देखना. यहाँ पे भी है. लेकिन आपको उतना सब जानने की जरूरत. आपको सिर्फ ये दो. They are given only these 2 examples. 2 examples. Look here. This is defect. This question will come for 2 marks. Why don't you just Dalmia, uठ जा वहां से अभी जरा मैं. I'll make you sit in that restroom. Okay? What man? Yeah. Anomalous pair. Please. Defect. This will. Certain elements having higher atomic weight. They are given. बेटा अगर आप खाली टेक्स्ट बुक पढ़ेगे कुछ समझेगा नहीं. मैं तुमको ओरिजिनल टेबल आई एम शोइंग यू एंड आई एम एक्सप्लेनिंग दैट. सो नाउ यू आर इन अ बेटर पोजीशन टू अंडरस्टैंड आल्सो. So look, and the same values are here or not? Tell me, beta. Look, clear? So a small elements having higher atomic weight have been given position before the element having lower. So this is the anomalous pair. Which is the anomalous pair? Cobalt was placed before nickel. And they have not shown here this. Can you see here? Have they written anything about this? No, no, you won't understand. In this table, they have not also showed what? They have not also showed what? That empty space. यहाँ पे है क्या नहीं ना? But it was there in the table which I showed. I am going to share this table in the group also. Look. देख ये देख रहा है बेटा. दिस एम्प्टी स्पेस आपको दिख रहा है ना बेटा? देन दिस दिख रहा है एटॉमिक एनोमलस पेयर भी दिख रहा है कि नहीं?
So what about the other empty space?
That you don't have. Whatever you have, that only I am
What
telling.
is it? What is it?
What only जितना
अरे यार ये मैं
जितना मैं बता रहा हूँ, जितना तुम्हारे टेक्स्ट बुक में वही बता रहा हूँ. ओके. The next one. The next one. The next one I'm going to show. This is very, very important. Come on. Then a position of isotopes. Acha beta, now tell me, Shetty, how many isotopes of hydrogen we have? You know, 3. H1, 1, 2. हाँ, प्रोथियम, ड्यूटेरियम एंड ट्रिटियम. ठीक है ना बेटा? प्रोथियम, ड्यूटेरियम एंड ट्रिटियम. ओके. हाँ. Now he arranged the element on the basis of atomic mass. Okay, isotopes have same atomic number but different. So according to him, hydrogen should have occupied 3 different positions or not? Tell me. Yeah, I think so. No, according to his, but in his table, hydrogen was only at the first position. So the position of isotope is not justified. But how I can justify the position of isotope? On the basis of atomic mass or atomic number? Atomic. So look, isotopes can be placed in same position on the basis of atomic number and not on atomic mass. Clear? Acha, if you see his table, in his
Atomic number without the arrangement, how do you know if it's 1, 2, or 3?
which one? Atomic number is on the basis of the protons present in an element. It is not related to this. Okay?
तो हाइड्रोजन का मास 1.01.
हाँ, तो ठीक है ना. तो हम लोग अप्रोक्सीमेट लेके, हाँ, अराउंड. अच्छा, इसके टेबल में आपको यहाँ पे ऐसा 2 अलग से सीरीज नजर आ रहा है क्या? ऐसा 2 अलग से सीरीज नहीं ना? दैट इज विच बेटा? लैंथेनाइड एंड एक्टिनाइड. सो इन इस टेबल पोजीशन ऑफ लैंथेनाइड एंड एक्टिनाइड वाज नॉट जस्टिफाइड. हम लोग मैं बताने वाला तुमको. हाँ बेटा, लेकिन वो जस्टिफाइड नहीं था उसको, मतलब देयर वाज नो पोजीशन. बट आई कैन नाउ, after discovery, they came to the conclusion that lanthanide and actinide should also be there, but that was justified by on which number? Atomic number. So look here, what was this drawback? Anomalous pair, position of isotope and position of rare earth and actinide. Rare earth means lanthanide. Could be justified if elements are arranged on the basis of what? Atomic. Clear? I am going to share his exact table also, beta, in the group. Now, beta, the new gentleman came with the new thought process, and there was no beta. So far, everybody was arranging on the basis of what? Atomic weight. Listen, this boy here, everybody was saying on the basis of atomic weight. But now a new gentleman came with the new thought process, and he said that not atomic weight, but atomic number. What was his name? Henry Moseley. Henry Moseley.
26 years old.
Yeah, Henry Moseley. Oh, young boy it is. Hey, what is atomic number? This boy here, look, atomic number is what? No, you only had that doubt. No? Atomic number is number of protons. Girls, number of protons or electrons. Okay. Shh. Hey, he arranged the element on the basis of atomic numbers. So his law, what was Mendeleev's law? The physical and chemical properties of element are periodic functions of atomic weight. But he said that the physical and the chemical properties of element are periodic functions of atomic number. This question I can ask in MCQ. Okay, listen. Henry Moseley. What is his law? What is he arranged the element on the basis of dash? So we'll say atomic weight or atomic number. Right. Mendeleev then atomic weight. Tobirainer then atomic weight. Newland then also atomic weight. Now beta, let us see his table beta. His table is this one beta, horizontal, and the new table I am going to show. Look here. This is the table. Look, this is the layout. Horizontal. First question. What are periods? What are periods? Horizontal row in the periodic table are called periods. Vertical columns in the periodic table are called groups. Hardik Pandya, horizontal period. You'll remember beta, Hindustan Petroleum otherwise. Horizontal period. What? Vertical column are known as group. Vertical column are known as groups. How many horizontal row and how many periods? Let us see. Let us count. ये number देख. ये शेटिया. ये यार मारेगा भी देख. 50 निकालेगा तेरा इतना है. मार शेफ्टी निकालेगा तेरा. शेफ्टी means पूछ. Tail. समझा ना बेटा. ज्यादा ज्यादा बात किया ना तो शाइन से शिल्पा बनाएगा. ठीक है ना. हाँ, शाइन शेट्टी से शिल्पा शेट्टी बनाएगा तेरा नेम. हाँ, ठीक है ना. माय गॉड. हाँ. Oh, I can imagine you or you're singing on that dance also. Okay. Okay. बस. Time pass.
I swear, I saw it.
How many vertical columns are here?
Oh, I will take that.
18. Vertical column is 18. Very 18 vertical columns. How many periods are there? Let us count in modern periodic table. The one in purple I am writing. How many purple? 7. 7 ही नहीं. वो दो नीचे के बेटा यहाँ से आए और ओरिजिनेट होते. They are actually placed here only. So there is only 7. Remember. 7. हाँ, तो मैं बता रहा हूँ, सब बता रहा हूँ. पहले देखिएगा. Only 7 periods and 18 vertical column. So what I want all of you to do in your textbook, beta, very important thing. This is your page number, I think 82. Yeah. In page number 82, why don't you just shut your mouth, all of you and parents. Okay. 7 horizontal rows, periods. 18 vertical column, groups, underline. Modern periodic table. What is the basis of this question they will ask? What is the basis of modern periodic table? Increasing order of atomic numbers in 7 horizontal row and 18 vertical forms the basis of modern periodic table. Then very important, what is modern periodic law? The physical and chemical properties of element are periodic functions of atomic number. Atomic numbers. Okay. Now, a very important thing I am going to discuss with you all, beta. Okay? So let us start about this thing. Now, beta, they told how to find the position of an element. This is very important. I want all of you to write this. How to find the position. This is very important and this will come in exam. पूरा नहीं कुछ लर्न नहीं करना, मैं तुमको बताऊंगा सब. But this no, this you have to write it. Chalo, start writing. Very important point. How to find? I am discussing position of element. Period number. How to find period number? Period number. Period number is number of orbits or shells. Number of orbits or shells.
Getting stuff the school. Photo anything कुछ भी नहीं.
Right hand side.
Right now chemistry.
Right hand side.
If in exam they tell you, yeah, bye. Why don't you just shut your mouth and start writing? Group number. How to find group? Group number. How to find group number? The group number we can find on the basis of valence electron. We can find group number on the basis of valence electron. Valence electron means which electron? Outermost electron. Which electron? Okay, it depends upon the valence electron. If my valence electron is 1, therefore it will be which group? Group 1. Group 1. If I have valence electron, how much beta? 2. Then my group will be group 2.
कैसा टेबल है ये?
मैं बताते ना रुकेगा क्या?
नहीं,
Okay.
right.
If valence electron is 3 or more valence electron, 3 or more valence means which electron? Outermost electron. 3 or more valence electron. 3 or more valence electron. Then how to find your group number? If you have 3 or more valence electron, then what you have to do? Valence means outermost electron. Then what will be your group number? Therefore, group number will be 10 plus. Just shut your mouth and do your work. 10 plus this. 10 plus valence electron. If I have, now listen. Hey, sorry, beta, listen. If I have 3 valence electron, then 10 plus 3, 30. If I have 4 valence electron, then 10 plus 4, 40. If I have 5, then 10 plus 5. 6, then? अच्छा 7, then? 10 plus 8, then? बस उससे 8 के बाद कभी वैलेंस इलेक्ट्रॉन हो सकता है क्या? नहीं. Understood? ना? Copy this. Yedi. Copy कर. Done. This you have to write full. Now, very nice. वो क्या? ये तूने क्या सम रॉन्ग किया है? क्या किया था? इंक्रीजेंस बाय था, बाय लिखा था वहां पे, ऐड किया ना? हाँ, सब देखा मैंने.
वो ChatGPT सर से
ChatGPT sir.
it's not 1000 Ravi sir it's correct.
हो गया तुम्हारा?
Sir, कुछ
मैंने तुमको उस दिन भी रिवीजन क्लास किया था, तभी भी बोला था बाय मींस. बस.
But in Google it's showing 1000.
Shut up.
Sir, Google is showing 1000. Exactly, sir. Google is wrong, sir. Yes, smart, sir.
Beta, hey, let me tell you, Google is not an authentic source. Let me tell you.
Sir, but sir, yes,
Ravi sir said he's not going to give up. Don't see.
Hey, hero, bus. Hey, bus. Hey,
Zero.
He'll give you 2.43.
this boy here, enough. Hey, Tanisha, बस हो गया, देगा. चलो बेटा, first sum. Hey, this Ruby will answer this now.
Oh,
Okay,
great.
in exam they will say, first example I am going to do. Have you all copied this?
Yeah, sure.
Example number 1. In exam they will say there is an element X. Its atomic number is 20. Its atomic number is 20. And they will tell you to find, listen, listen. They will tell you find the position. So first what you will do, Ashlesha, first always you will do what? Write electronic configuration. So what is the electronic configuration, Ruby? 2, 8, 8, 2. घर पे जा, तेरे को जितना बोलता है उतना करना, शाना मत बन. हाँ तो पीरियड नंबर 5 तेरे को कैसे मिलेगा ये? हाँ तो ऑर्बिट कितना है? हाँ तो देन शेल और शेल्स. हाँ, ऑर्बिट और शेल सेम ही होता है. एक थाट नहीं तो पहला देख, पहले ये शाना बनता है. how many orbit you are having here? Can tell me? 1, 2, 3 and 4. So what is my formula for period number? Tell me number of orbit or shell. So how many period? Come on, tell me. Very good. Period 4. आ गया. Now what I have to find? Group. ये बोका बोल, ग्रुप के लिए क्या करने का है? ग्रुप के लिए क्या करेगा? पढ़ना यहाँ पे. ग्रुप नंबर इज व्हाट? वैलेंस इलेक्ट्रॉन है. अच्छा, वैलेंस इलेक्ट्रॉन तेरा 1 है यहाँ पर. देख यहाँ पे वैलेंस मतलब आउटर मोस्ट कितना है यहाँ पर? 2. तो 1 रहता तो ग्रुप 1, 2 है तो ग्रुप 2. हो गया. चलो कॉपी करो ये एग्जांपल. एग्जाम में ऐसा क्वेश्चन आएगा. हाँ तो इजी है ना, तो आएगा ऐसे. ये बहुत बहुत इंपॉर्टेंट है. वेरी वेरी इंपॉर्टेंट.
So could you just repeat this part? I didn't understand.
What बेटा?
So could you just repeat this part? I didn't understand.
Why don't you, Bhutia? What are you doing, man? Look, I'll show you, beta.
Sir,
What?
I
How
had to
to
go
find
out.
period number? Shut your mouth. Period number is what, beta? Number of orbit or shell. So this element was X, 20 atomic number I was given. So do you know how to write electronic configuration? Tell me, dear. Come on, Vivan, tell me.
Yes, sir, of course.
2882.
Yes, sir,
So
of
how many
course.
orbits you can see here? 4. So period number is 4. Understood? How to find
Oh,
group
okay. Huh.
number? Group number will
Yeah.
depend upon the valence electron. If I have one valence electron, then it will be in group 1. If it is 2 valence electron, then it is valence electron means outermost electron. But if it is 3 or
Yeah.
more valence electron, then what I'll do? 10 plus those valence electron. Okay. Now you tell me here
So,
how
so
many
there's
valence electron are there? Vivan, tell me.
two.
2.
Two,
So
two.
valence electron is 2. Therefore group 2.
Group
Understood?
2.
I am
So there's
giving now
no
second example. All of you have
group
copied
7.
this. Are you ready for the second example? Ashlesha, you are going to answer.
What do you want me to call it? The dinosaur?
Hey.
Done.
Done. Ashlesha. Shh. Hey. There is an element. Example 2. There is an element Y. Its atomic number is 17. So now what you will do? First write electronic one. 287. So how many orbits are here? Very good. 1, 2, and 3. So what will be the period number? Period number is number of orbits. So which period it will be? 3. Now we have to go for group. Group में बेटा what is the group number के लिए क्या है बेटा? Valence electron. Is the valence electron here how much? 7. Is it 1? No. Is it 2? No. So it is 3 or more than 3 or not? Tell me. So whenever it is 3 or more, what is the formula? 10 plus that valence electron. So 10 plus. So what will be my group? Okay. Copy the second example. That is not for your syllabus. Not for your syllabus. That is related to beta SPDA. That I'll teach you later. Off bound with This Diya, we'll do the next one. Diya, na? Kya naam hai iska? Diya, na? Diya. Okay, Diya. You are going to, Diya, you are going to do the next one.
Chal Diya, I believe in you. Shine bright.
Black diamond. Black diamond.
Beta, both of you depend on each other, remember. Okay?
What is sense like that?
Yeah. Remember, he will bring light in your life. Okay?
So I
Yeah. This, Diya, beta, यहाँ पे देख. Okay. Hey. Third one. There is an element M. Its atomic number is 6. Hey, I want all of you to do this on your own. I'm not going to help you.
Sir, Diya को work करना.
Diya करेगी.
Easy. 2,4.
Yeah.
Group is 40.
Boy.
Atomic. First, we have to write electronic configuration. Diya beta 2,4. And this was atomic number 80.
4, 10 plus 4.
No, first tell me which period.
Send you back to that family.
Diya, please.
That's 40.
How many valence? How many valence electron is here? 4. So it is 3 plus 4.
Say Tom and Jerry first of all.
Black anyways.
Oh.
Chalo. Hello. Now the next one.
Constitution right before equality.
There is an
I swear, Tom and Jerry. Sir, मेरे को ये लोग नहीं पता. ये लोग नहीं पता. ये नहीं पता. Sir, और मेरे को पता next example. ये दिया है.
next example you are going to do on your own.
Yes, sir.
There is an element Q whose atomic number is 11. Do on your own. Do on your own. अबे क्या के लिए इलेक्ट्रॉनिक कॉन्फ़िगरेशन लिखना है ये
Period 3 group is 1. Yes, sir.
So how many period is there?
Period 3.
Orbit. How many orbit?
3.
So period is now for group what we do? Valence electron. How many valence electron are there in the outermost orbit? Bolo na. So A, if it is 1, then it is group.
That was bad.
Online students, are you getting it, beta? Hello, group 1. Hello, group 1. Is this clear?
Yes, sir. I'm getting
50.
it.
Yeah, very good, beta.
Period.
Yes,
Very good. You
sir.
are doing perfectly fine. Any doubt, anyone? Anya
No,
Mehta,
sir.
you have any doubt?
No, sir.
Yeah. Dingra, Shravan, Shanvi, Hisha,
No doubt, sir.
Aditi.
No, sir.
Now,
अबे बचाओ
now this is very, very important. Please. Number क्या था बोल बेबी? 5. Please. 5. Hey, there is a. Yeah, bas. Very good, beta.
This is the joke.
This girl here, Arya, you are going to do this. यहाँ पे वहां पे मत दे, बुक बंद कर वो पहले बंद कर पूरा. There is an element Z whose atomic number is 2. All of you think electronic configuration is 2. So how many orbit? How many orbit? So period will be 1. Period 1. अच्छा एक ग्रुप नंबर के लिए क्या देखने का रहता है बोलो? वैलेंस. If 1 then group 1, 2 then group 2. So how many valence electron are here? एक ही मतलब valence electron is 2 only ना बेटा. Therefore group will be what? 2. Right beta? Okay. All of you are wrong beta.
Sir, it's not it's an 18.
Exception.
Sir, it's group 18.
Hey, although it was having only 2 electron, it will be not group 2, it will be group. बेटा मैं बता दूं ये कौन है तुम्हारा? हीलियम है ये. हीलियम इज अ नोबल गैस. नोबल गैस आर प्लेस्ड इन
Yes.
ग्रुप 18. बहुत इंपॉर्टेंट है. ऑल नोबल गैस. ऑल नोबल गैस. हीना, नीना और करीना के जेरोक्स रंगी. Okay? Please, this is the exceptional case. Mark this very, very important. Now, I will just अच्छा ये पूरा कॉपी करो. ये बहुत सब बच्चे रॉन्ग करते हैं. आप लोगों ने भी रॉन्ग ही किया था स्टार्टिंग में. सबने रॉन्ग किया था. ये इसी के साथ हम लोग आगे बढ़ेंगे बड़ी खूबसूरती के साथ. चलो बेटा आगे बढ़ते हैं. Oh yeah, be careful, be gentle. Yeah. Now बेटा और 2 है तो ग्रुप 2 में ही होता है, खाली एक ही पूरे पीरियोडिक टेबल में यही एक्सेप्शनल है। हाँ, नहीं है आपके सिलेबस, वो बेटा एसपीडीएफ पे होता है, वो मैं बाद में बताऊंगा। हैव पेशेंस, तुम लोग को है ही नहीं, नॉट इवन इन 9th, नॉट इवन इन 10th, यू हैव ओनली ग्रुप 1 2 एंड डायरेक्ट 13 to 18 बस। अरे once we complete this chapter, I'll tell you na beta. I will also tell you why in periodic table on the left hand side there are 2 column only. Why there are 6 in between, why there are 10. Everything I'll tell. Don't you worry. We teach this for 11th and 12th for JEE mains, NEET and medical. Okay, right? That day, what was that, Anya? Okay, wing. Yeah. Anyways, yeah. Anyways, that Anya Mehta did, I guess. Anyways, chalo, bas. Have you all understood this?
No, what? What did I do?
Listen. I'm going to show you directly your table. Okay. I hope all of you copied this, beta. Now look, this is your exactly the table here. Okay. Acha, let me tell you. Below this is group 1, group 2, 13, 14, 15, 16, 17, and 18. Here, beta, you have like this. This is group 1, 2. Can you see here? There are 14 elements below. This is lanthanide. And this is what, beta? Below this, actinide. I'll tell you what all this thing is there, beta. Okay. Now, can you see the noble gas? Helium यहाँ पे दिखा कि नहीं? Group 18. Okay. Now, listen carefully. Listen carefully. Carefully.
You should. What? Slowly. अभी तू देख तेरा it's too appropriate biological gross
Okay. I'm just giving the introduction. Yes, beta. I'm just giving introduction and then I'll leave you. Pay attention.
What happened?
Look, beta. Now for your syllabus, what all thing we are going to study, beta? Okay. Just first, I'm just giving introduction. Hey, baby. Hey, babies and Baba and the rest, please pay attention. Okay. 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 Please. Okay. This, please. Group 1 is known as alkali. Boys. Group 1 is known as alkali. Group 2 is known as alkaline earth. Group 17 are known as halogen. Group 18 are known as inert gas. Now, can you see this 3 to 12? They are known as transition. They are known as... And can you see between this 56 and this 72, there are certain elements. This is lanthanide. This is... It is inside the transition. Can you see it is inside the transition? Therefore, we call it as inert. Achha, why they are known as alkali, why they are known as halogen, why inert gas, that I'll explain in the next class. That's all. I'll explain all this in the next class.
But my grammar isn't there.
Chalo then, bye-bye everybody. Bye-bye.
Bye, sir. Thank you.
Bye, sir. Thank you.
Bye.
Bye, sir.
Bye, sir. Thank you.